be followed by the computer in working out the solution and assembling the raw data to be processed by the computer. As a programmer, you may decide to draw up a process diagram as an aid in getting organized. Such a diagram enables you to set up the facilities the computer will work with: input medium, output medium, auxiliary storage if needed, and source documents. You use symbols to show the various items. The input medium may be punched cards, a file of punched paper tape, or magnetic tape. Auxiliary storage may be magnetic drum or discs, or magnetic tape if high-speed or random access is not essential. The source documents provide the data to be entered on the selected input medium. The output medium may be cards, paper tape, magnetic tape, or reports, which will require the use of a computer system high-speed printer or a typewriter. These symbols, incidentally, have been adopted as military standard. In making up the diagram, you choose the facilities best suited to the problem at hand. Your next step is building the flow chart of the various steps required to process the data. As you decide on the logic to be followed, you construct a chain of symbols that show every operation to be performed from start to finish. These flow chart symbols are from the military standard specifications. This shape is used to indicate the start and the stop of the program process. The rectangle represents an operation, either a transfer, such as moving data from the storage or memory to the arithmetic unit, or the operation may be arithmetic. The diamond applies to logical operations and indicates a decision to be made, a question to be answered, yes or no. This is known as branching and may result in changes of instructions. This shape represents a subroutine, such as table lookup, sorting, or some other set procedure to be followed. A circle with a number in it is used to indicate that the flow goes to another part of the chart to a similarly numbered circle. This is a very simple example of a program flow chart. After start, an operation is to be performed, such as adding two numbers, for example. On the basis of the result, a decision is to be made, such as determining whether the sum is equal to or greater than some given value. If the answer is no, another operation is to be performed, such as taking another pair of numbers from storage and repeating the initial operation. As long as the decision is no, the repetition continues, using new data each time. When the decision is yes, a subroutine is to be performed, such as extracting the square root, for example. In the next operation, the result is to be printed out. Stop indicates the end of the program process. Of course, flowcharts are rarely this simple, but are made up in a similar way. The program then takes form in the flowchart, and you build it symbol by symbol, line by line. It may have to be drawn up in sections. Many programs are large undertakings, often requiring weeks or months of work and the combined efforts of a team. The completed flowchart shows what the computer is to do, but information in this form cannot be understood by the computer. It must be converted into computer language. That is your third step, coding the instructions. As the programmer, you may do it, or you may turn it over to a coding specialist. Coding is translating the steps of the flowchart into computer language that the computer can read and store and then act upon. To see in a small way what is involved, Let us suppose an operation calls for computing the values of x in this equation, using various given values for A, B, C, and D, and then printing out the solutions. We will follow the process for one set of data, 24, 36, 48, 60. Now the flow chart for this problem is a simple one. The key operations are start, multiply the first two numbers, 24 and 36, multiply the third and fourth numbers, 48 and 60, add the two products, print out the answer, and stop. You begin coding by deciding where you will store the data, let's say in these addresses in the computer storage unit. In addition, you will need to include data transfer operations and to express these instructions in computer language, numerical words. Each instruction word is a group of digits, say 10 in this case. You use the first two to specify the types of operation by code numbers such as 21 for transfer from storage and multiply, 22 for transfer from storage and add, 23 for transfer from accumulator to storage, and 24 for transfer from storage and print. The next four digits and the final four will represent storage addresses of data. Now the first instruction word is this: transfer from storage and multiply the contents of address 2001 by the contents of address 2002. Note that the instruction does not contain the data to be processed, just the addresses where they are stored. Obeying this instruction, then, the computer will multiply 24 by 36, and if, like most computers, will leave the result, 864 in this case, in the accumulator in the arithmetic unit. Your next instruction word is this: transfer from accumulator to storage the contents of the accumulator, which may be indicated by 9999, to storage address 2005. For the next step, the instruction word is transfer from storage and multiply the contents